Hi everyone. I wanted to make a few extra videos this week because in lesson 8 in the solving rational equations algebraically part, there was only one video to show you how to solve these algebraic. So I took the 4 problems starting on page 309, number 33B, and you'll see the ones on the next page on 310. I have a short video for each one of these to help you along this week. So we're focusing, in this video, I'm focusing on the algebraic method to solve a rational equation. Okay, so let's look at this one right here. We're trying to solve 1 equals 5 over x minus 2 minus 3 algebraically. So what I usually do on the side before I even start these is I usually try to take note of what values for x are not allowed to be in this equation, where x is undefined. So I look at this denominator, I look at any denominators that I have, and this one only has one single denominator of x minus 2. So I know I can't divide by 0 ever. Okay, so I know that I'm going to write this over on the side. A lot of times I write a little box for my students, and I make them write out what is x not allowed to be. Okay, so x is not allowed to be 2 in this case. If x were 2, we end up dividing by 0, which is undefined. Me doing this ahead of time will just kind of keep track. You know, if I get a 2 in the end, I have to reject it. And sometimes we forget to do that little check at the end. And if we do this at the very beginning, it helps us to remember what values we're really looking out for to make sure we reject. Okay, so now we're ready to start actually solving here. So we're going to now look for, when we're trying to solve these, the first thing we're going to do on this one is I'm going to actually bring over that 3, okay? I'm going to get this rational term by itself on one side. This is easy enough to do, and it cleans up my equation quite a bit. So I end up getting a 4 equals 5 over x minus 2. A lot of times there's no easy way to get the rational part by itself. You'll see in the next examples we have multiple rational expressions within the equation. But this one, adding over the 3, gives me one less term to have to worry about. So now I'm looking to figure out what the lowest common multiple is so I can multiply through with it. And since this only has one fraction, right, we only have that one fraction, my lowest common multiple that I'm going to multiply through with is x minus 2. So I'm going to multiply both sides by this x minus 2. And now we don't actually distribute on the right-hand side because the whole reason we chose x minus 2 was to cross cancel. So don't let yourself, distribute anything on that side that you're trying to get rid of the denominator. What you chose for your least common multiple should cancel with the denominator. So by the end of this step, by the end of this one step, we should have no fractions left. Okay, and so now I see on the right-hand side I have a 5. See, no fraction there. And on the left, okay, now I have to distribute this. So I'm going to make it a 4x minus 8. I want you to take note of what kind of equation we have here because it's going to come up in the next few examples. So this equation that I have, that I created, okay, by multiplying by the LCM, this equation is linear. So I know that because I have the highest power is x to the first. So by you looking at that and recognizing it as linear, it will help you solve this easier. You have to constantly look at the equation and say, if it's linear, okay, if it's linear, I get x, all my x's on one side, all my numbers on the other. If it were quadratic, then I approach it differently. So I want you to just look at them and notice what kind of equation they are. All right, so this one, since I have a nice linear equation, I'm only going to expect one solution. And so now I'm going to just start getting my x by itself. Okay, so I'm going to add over my 8. I'm going to solve this new equation. So I'm going to get 4x equals 13. And I'm going to divide out my 4. And x equals 13 over 4. Okay, so I want to talk just a little bit about the checking part of these. Now this check would be, it will still work. And if you wanted to make it into a decimal, you could. Because when I divide by 4, if I wrote that as a decimal, it's not like it would be a nice ending decimal. So it would be okay to do. It's not like I'd have to round it. The reason we have to check these answers and make sure this is not extraneous is because it has a fraction in the beginning with a variable in the denominator. By me doing this at the beginning, what we did right here, I'm just circling it again, right? By me doing that, that's really the only value I had to keep in mind that I'd have to reject. That would be the only extraneous one if I got a 2. So as long as I keep in mind that, then this will be okay. This will be a valid solution. I did not get a 2, so I should not have to reject any values. I can always just go back up and put the 13 over 4 into my equation to make sure it works, but as long as it's not the value that makes the denominator 0, it will not be an extraneous solution. The reason we have to check for these extraneous solutions is because when I started off right here, right at my beginning equation, that was a rational equation. And by me multiplying by the LCM, when I got down to this point right here, I made that equation into a linear equation. So I changed the actual type of equation it was. And that's the same thing when we had to do it back in square root equations where we had to check our answers because we changed the type of equation along the way. And there's only a very few types of equations that we do that for when we solve. And this one and the ones that we did in the last chapter are some of those. Okay, so I hope you come back for my next video so you can just flip the page over and it'll be on the 3 that you see on page 310.